This video is going to be about electromagnetic waves. Electromagnetic waves are unique from mechanical waves in the fact that they can travel through a vacuum, so they don't need a media to propagate. The way they do propagate is by oscillating electric fields and oscillating magnetic fields. These are shown in the diagram here. So in pink, I have my oscillating electric field, and in blue, I have my oscillating magnetic field. Notice that they are at perpendicular to each other, and the propagation of the wave is perpendicular to both the electric field and the magnetic field. So my electric field's going up and down in this diagram, my magnetic field's going left and right, and my speed of my wave, C, is going toward the x direction. Electromagnetic waves are all transverse, and they all travel at exactly the same speed in a vacuum. And that speed is 3 times 10 to the 8 meters per second. Okay, now let's talk about the different kinds of electromagnetic waves there are out there. So now let's talk about all the different types of electromagnetic waves. So we said before that they all travel with the same speed in a vacuum, 3 times 10 to the 8th meters per second. But different electromagnetic wave types have different wavelengths and different frequencies. So as you can see on this diagram here, so the highest frequency is on the right, and the lowest frequency is on the left. Conversely, the largest wavelength is on the left, and the lowest wavelength, the shortest wavelength, is on the right. So this tells me that for electromagnetic waves, the wavelength and the frequency are inversely proportional. So as a wavelength gets larger, frequency gets shorter, smaller, and as wavelength gets shorter, frequency gets higher. The waves with the shortest wavelength are gamma rays, and they also have the highest frequency, so that you can find them here on the right. Gamma rays have the shortest wavelength and the highest frequency. If we look on the far left-hand side for the lowest frequency and the largest wavelength, we see that we have radio waves out here. The electromagnetic radiation that we can see is only a very, very small portion of the electromagnetic spectrum. So we're only able to see 700 nanometers to about 400 nanometers in terms of visible light. You're going to be responsible for knowing the order of magnitude of the different wavelengths of electromagnetic radiation, and you'll also need to know that the order of the wavelengths of light for the visible light spectrum. So you'll need to know red has the shortest wavelength, followed by orange, followed by yellow, followed by green, followed by blue, indigo, and violet. So you can remember that by remembering that Roy G. Biv. It's a good way to remember the order of the colors in the visible light spectrum. So red is the shortest. Red is the longest Red is the longest wavelength over on the left-hand side of the spectrum, and blue has the shortest wavelength over on the right-hand side of the spectrum.